Hey guys, in this video we will be looking at horizontal stretches of functions.
So in general, guys, for any function y equals f of x, the graph of y equals f of bx, where b is any real number, results in a horizontal stretch. So in this case, y equals f of x was horizontally stretched by a factor of 1 over b. And I'll explain this to you guys later in this video.
Alright guys, let's start off by drawing a graph again. Let's go. Y equals root x. Now let's graph this function. So it will be at the origin point, and when x is 1, y will be 1. When x is not 2, but when x is 4, y will be 2. And when x is 9, y will be 3. So right here. And we can connect these dots, draw a curve like that. So the brown function is our y equals root of x. Alright guys, now let's draw the function y equals root 2 of x. Now it will still be at the origin point, but now when x is 1/2, y will be 1. So when x is 1/2, y will be 1. And when x is 2, y will be also 2. So it will be right here. So when we connect these dots together, we will get y equals root 2x. But as you guys can see, even though these 2
points, even though they have the same y value, their x value became different. The orange x value is 2, while the brown point has an x value of 4. This shows us that the orange function was horizontally stretched by a factor of 1/2, because this was 4, and if we stretch it horizontally, it became 2. It is the same for other points. Let's look at these two. Brown's x value is 1, while the orange point is 1/2. But their y value is the same. So when we horizontally stretch a function, we write it as 2, but in fact, the orange function was horizontally stretched by 1/2 because all its x values are being decreased by a factor of 1/2. And for its mapping notation, we can say that x comma y goes to, now the y value doesn't change, but our x value changes by 1/2. So instead of writing like 2x, because there's a 2 here obviously, that's not correct for horizontal stretches. It will be a half, or the inverse of 2.
Alright guys, let's look at another function. Now we have y equals root 1/2 of x. Now its origin, it will have a point at the origin, but now when x is 2, y will be 1. And when x is 8, y will be 2. And if we connect these dots like that,
the curve isn't that great, but if we connect like that, we can see that all of its x values have doubled. So here its point was 4 comma 2, but now here it's 8 comma 2. So this orange function is a horizontal stretch of this function by a factor of 2. Remember, when we horizontally stretch a function, we basically flip this over, so it's 2 instead of half. And we can write the mapping notation as 2x, oh sorry guys, my bad. So x comma y goes to 2xy. So the y value stays the same, but the translated or transformed function function's points x coordinates become doubled. Alright guys, to sum it up, when we have the function y equals f of x, if we want to horizontally stretch this function, we put a number like that. And say we want to horizontally stretch this function by a factor of 3. So we want to like triple the value of the x points. Then we write it as f of 1 over 3x. Because this number will be flipped so that when we write it in mapping notation, it will be x. And then arrow goes to 3xy. So we always flip this number. So this will be a horizontal stretch by a factor of 3 instead of 1 over 3. Alright guys, so thank you guys so much for watching this video, and stay subscribed for the next video of this pre-calculus series.